Hello everyone, my name is Renaldi Antonio and today I will present our uh, research about car tracking with Euclidean distance tracking algorithm and YOLO algorithm. I've done this research with my friends Stephen Farrelio Jorgensen and Raien Ronariv with the help of our lecturer Mr. Achmad and Mr. Rhio Sutoyo. So first of all, our main goal of this research is to help solve the problem about traffic congestion and traffic monitoring issues because those problems have caused many other problems such as stress amongst the driver and high pollution concentration in one location. And to solve this problem, we can use AI, and there are so many algorithms we can use to with this AI to solve this problem. And in this research, we use Euclidean distance tracking and YOLO algorithm with the help of deep sort to detect and track cars between intersections. And after we track the count of the vehicles between intersections, we send the data to the motherboard, and the motherboard will control the traffic light based on how many cars on each intersections. So the least amount of, I mean the highest amount of cars in each intersection will get a green light first. So our related works, we took about 12 related works, and there are some research on how to reduce traffic congestion, some literature reviews from regarding traffic jams, and similar topics regarding car tracking to reduce traffic congestions. And our methodology, uh, first of all, we took our dataset from YouTube with the keyword of traffic video for object tracking, and after that we download the videos, we put them into our IDE with the help of Python language, and in the code we cut the video into desired size, as you can see on this left side here. We cut the video into a smaller size because we don't need, I mean, the original size was much. There is so much details in the larger size, and we don't need we don't need that much details on our camera because we only need what's in front of our camera, which is what's in front of the traffic light. So after that, we convert the video into black and white format, and as you can see here, the white part shows moving objects. And the problem with this Euclidean distance tracking algorithm is we can see that there is some small white parts here, and that is no other than the traffic lines. Why is this happen? Because when the camera is moving, they track some object as moving objects. So that is some problems for this algorithm. And moving on, after that we put green rectangle on the moving objects like this, and after that we apply the Euclidean distance tracking algorithm to track the moving vehicles, and we put a number on top of the moving objects to track the vehicles. And after that we analyze the result and we compare it with YOLO and deep sort algorithm. And this is the Euclidean process. It's the same as I explained before. From the start, we insert the video into our IDE, we cut the video into a smaller size, and we apply object detection per frame. We wrap the detected object with green square, and we track the object with Euclidean distance tracker, and we place an identifier on top of the track objects. And this is the YOLO architecture that we used. When the video is put into places, they were cut into small size, and that is 448 by 448. and then the output is this little cuboidal box here, and they were sent from this part to the other parts using CNN, and there was about 24 convolutional layers in this architecture. And the result is, in the normal traffic, as you can see here, the first video contains car and motorcycles, the second videos contains car and trucks, and so on and so on. And this is the vehicle count. And when using Euclidean distance tracking algorithm, we can only detect some vehicles. And then there was some error with the algorithm. Uh, the algorithm detects so much boxes in one vehicle, so that's the error. And because of that error, uh, you can see here the original vehicle count is only 23, and with Euclidean they count about 74 vehicles, which is more than what is the original vehicle count is. And using YOLO and deep sort algorithm, we count about 22 vehicles, which is close to the original vehicle count. And as you can see here, this is 35 and the original is 38, and the next one is 25 and the original is 27, and so on and so on. We show 0 on the Euclidean distance tracking algorithm here because the count is going crazy, about 100 or more, which is the vehicle count is less than 100. In the heavy traffic, the Euclidean distance tracking can't detect anymore because there is so much vehicles in one frame, and we decide to put a 0 on it as an error. And using YOLO and deep sort, they can detect and track the vehicles normally with their algorithm. And the foundation for this research is this algorithm. It's YOLO algorithm and Euclidean distance tracking algorithm. And the conclusion for this research is there were so many methods that we can use to solve this traffic congestion problem using AI, and the methods that we use is YOLO and Euclidean distance tracking algorithm. And the results is the YOLO algorithm has the upper hand because they can detect and track vehicles more accurately in both normal or traffic jams. And the Euclidean distance tracking has some error because they can detect multiple vehicles in one vehicles. And that's it for our research. Thank you for your attention and have a good day.